Thank you. All right, so I probably need to set it automatically to record, but because I'm using the school thing, is not set up that way. Doesn't happen automatically. All right, no. So, all right, so 20. So it's 20x. So the answer is 2.5 times minus 20, and that gives me minus 50. All right, so I'm getting a minus 50. The fact that I'm getting a minus 50, I am where now? I am, so minus 50 is somewhere down on the scale. So it means therefore, so minus 50 is down here. So it means that when it crosses all the way across and it spans over the what? 2.5. So see it here? So it's a slope. It maps out a triangle area, this area here. So 0 and over here, so it's corresponding to minus 50. So right now we're at minus 50 right here. All right, and it's a straight. It's not a, remember guys, it's not a thing there. Let me just clean it up. It's really straight. I'm trying to go over it. Let's see if I can make it a little bit better. Wow. Huh. Right, I'm getting here is so fine. Oh, come on. All right, that's a little bit better. So that's a little bit better. So that's minus 50. All right. When it is when the shear force is 26, the bending moment is minus 26x plus 115. Let's check it out. So we put in the first value, 2.5 times 26x. Now let's see what we'll get. So it's 26 times 2.5, and it's minus. So we're getting minus 65 right there. All right. If we get minus 65 there, it means therefore that something is wrong. Let us check that again. All right. Was it positive 26? Oh, yes, it was 26. Let's check that because something seemed to be off there. We should be getting 50 right there. So we're going to have to check back that formula. We're not getting back the correct thing that means that there's likely an error. Let's check it back to see what would have been the issue here. All right, at this point, so I want to just double check here. All right, so we said that m minus 46, all right, and what was the distance here? The distance was 2.5, and down here was x. So let's see if we had transposed that correctly. So this was 46 times x minus 2.5, right? Plus, where is this 20x? So we had a 20x coming over here, so which was a positive. This moment was a what? Clockwise, so we got x minus 2.5. Let's just check the work in here. So it's 46 times that, we get minus 46 plus 46 times 2.5, 115, right? And then now we had a 20x, so we got minus 26 plus the 115. So I don't know what's seemingly the issues there, but we're not getting back our answer there. Let me just see. So it's 2.5. We go again. I am getting 65. I don't know what's going on here. Let me just look back if there was anything else we left out. How many forces? It was just two forces. What's there? And the distance, we just confirm everything was, so it was 2.5 at that point. That was for, let me just confirm, that was for the second part. Where am I? Right. That is starting of the second part. So it ranges from 2.5 to 5.6. All right. All right. So 26 times that. So we get 65 there. Not so certain why we're getting 65. It should be getting values in the range. The first one should start here. We have 50. The first one, it should be telling that it is 50. Obviously means that there's an error, because if we check the second one, all right, let me tell you how you can do some quality checks to know if you're on track. If we work out this, what is the shear force that we got from this point? If we just work out the error, it would have been 26 times what? 26 times 3. Right. So you're getting what? 78, positive 78. Right there. All right. But I am saying to you, we should really get 50 right here. Let me see. We should really get 50 there. And let me just see why that expression is not giving us 50 right there. It could mean that there's some error in the working out the algebra there. I'm looking to see what could be the possible error there. Not picking up an error there at all. So it's 20 times 2.5. That. All right. All right. All right. So let's go back to our problem. All right. So as I'm saying, this formula seems to have an error in it here. When I do my quality check, I am seeing that something is wrong with this formula, and I'm picking up what's wrong with it right there. Let me just check it back quickly. All right. So we had our shear force. Let's just double check. Our shear force seemed to be okay. Get some right. Our shear force. Let's check how many forces we have again. We have the 20, the 46, and that. And we have them, so minus, that's minus. And that's minus also for the shear force minus V plus 46. And that gives us, so that is good. We then know we cut it right here. All right, so we have one bending moment here, which is positive, right? Then we need to get the bending moment of this section right here, right? And we already surmise that that section is going to be x minus 2.5, right? And then, and it is also going in the clockwise, which is minus. Then now, at this point, we have the 20 times x, and that is positive. So let's see, not seeing why this is minus 46x plus 115, right? And this is minus x, all right? So, hold on, it says 2.5 minus. Let me just double check something here. Any problem? 1 second. All right. All right, the first point, I don't know, I need to have to check on what is happening with the first point, why that is working out that way. But the first point should give us back 50 or minus 50 right here. So, because what we have, it would have been what now? 2.5 times 26 should be given this out back, but we're not getting that from it. We're getting 65. So obviously there's an error. All right. But strange enough, so where I'm gonna put in 5 point. Hold on. Let me see if it's really incorrect. 2.6, 2.5 times 26. What we're getting? 65 minus 65, right? Let me just see. So it's minus 65 plus 115. Oh, it's correct. Oh, I'm sorry, it's correct. All right, what I'm doing here, I did a wrong substitution. You get here, so this part give you a minus 65, but I forget that I didn't have the 115. So the 115 will give you back positive 50. So well, no, it will give you negative 50 rather. Is it negative or positive? Let me just double check that. So it will give you 50, right? Um, I'm thinking that it should be really a negative 50. Anyhow, let me just double check that formula up there. So anyhow, that's it's correct, right? It's correct for the second part. Let me see, where's that second part, you know? Section B, which is right here. Right. All right, so it's correct. So it's minus 26x plus 15. Put 2.5 in that and you should get the 50. All right, so it is at 50, but the only thing I need to tell you that it's really minus 50. So it's really checking it. It's supposed to have been really minus 50. Instead of getting minus 50, I'm getting 50. All right, so the sign is seem a little bit off, but it tells you that it is right here. That's the most important thing. So it should be still at 50. Now, when you put in 5.5, what do we get from that expression? 20, that's a minus 26. Let me clear up that thing because I think it's confusing me. Let me just clear it up. This look like 2.5, and I'm just make sure that I have it in my head that it's 26. So it is really, it's correct. 26 here. All right, so let's put in the another range value here. If you put in 5.5, let's see what you get for 5.5. You will get 5.5 times minus 26. I'm getting minus 143 added to 115. So I'm getting 28. All right, that value now I'm getting 28 for that value there. So it means that when it is 5.5, the answer should be positive 28. I'm getting positive 28 though. All right. So let's jump in back and finish it up. So all right, what I'm saying now, let us sketch now. So we're moving from here. All right. So actually we get what? We get positive 50 at this point. It's correct, you know. We get positive 50 at this point. So we're getting, when you put in 2.5, you get positive 50. It is correct. All right, for the bending moment. All right, and when you put in, and a circle is because it's not the actual, when you put in 5.5, you are getting a positive what now? 28. So these are all positive. So let's check them out. So positive 50, if you get positive 50 and this is minus 50, take you back to 0. Do you agree? All right, so it's really it's gonna cross. So it's coming up and it's crossing at gonna cross at 0. So that positive 50 is gonna bring it up back to 0. Positive and negative 0, it bring you positive 50 and negative 50 bring you right back to here. So you come back to 0. Now the 28, when you leave this 0, is when it come to 5.5, you must be this point, it must drop you back to 20. Oh, that don't look too proportional though. Let me just clean up that. It's the graph is not looking proportional. Let's get that correct. All right. So see if we're on this right track now. So it's a little bit more like something like that. So this is 28. So over here on the scale, it will be 28. So all right, let's go through that again. So 2.5 into this expression give you 50. This was minus 50 already. So minus 50 plus positive 50, you know, it bring you back right here. Right? When you add in 5.5, taking from that, 5.5, remember now, when you drop in 5.5, it takes you back to a positive 28. So it's sliding, coming up from 0, right up to positive 28. So you drop there. All right, the next part now, we analyze CD. Let's go with CD. So when you put in, now we are what? Positive 28. So you can actually put it to positive. So your bending moment, your maximum bending moment so far is 28. You cannot use the minus 50 as your maximum bending moment, right? The positive value is what we call the maximum bending moment, whatever positive value you have above zero. So when you substitute our expression that we have for this region CD, let's examine it. First of all, we know our shear force was 14 up top. Now we're looking at this formula, this expression here. So we know that x lies between 5.5 and 7.5. When we put in 5.5, let us jump in and see what do we get. So it's minus 14 times 5.5. I'm getting minus 77 plus 105. And that is giving me positive, it's giving me another 28. So I'm getting 28. So it means I'm really at 28, which is correct. So I'm up here. It's just telling me it mapping. The value that we get down here is telling you that you're at 50 when it was in the second one. This one is telling you that I'm starting from that one, which is 28. All right. What happened? And this is at 5.5, which is mapping to 5.5. You look up here. This region is represent 5.5. So this is 2.5 plus 3, so it's 5.5. So right here is 5.5. What happened when I reach 7.5? How do I move from there? Because we're still at 28. We can drop in another value, which is 7.5. 7.5 in this expression, what is that value? So it will be minus 14 times 7.5. I'm getting 105. So therefore, I'm saying when x is equal to 7.5, m is equals to 105 minus 14 bracket 7.5. So we are getting 0, because that is 105 minus 105. So that is 0. So it's telling you that you move from here and you're coming down, and what is the range? It's 2. It's over a 2 span. So it tells you actually can map it down from up here to know where to drop that. So it's right there. So the difference with this one was that this one crosses 0. That was the trick about this part here now. This part here is a little bit more tricky to analyze because it crosses 0. It's not like it was here and it's above. Normally, so what happened for this part, it carried down to minus 50 for this part. But for over here, it must be getting a value. The value we're getting over here is positive 50, which carries it back to 0. So understand that's the difference between those two 50. Just like how I get 28 here, but it is above 0. So in other words, what I'm saying, when you put in 5.5 into the section BB expression, this one here, you will get a positive 28. When I put 5.5 into this expression, I'm getting positive 28 because it's above 0, so it's at the same point. When it changes between 0, it's analyzing it is a little bit different. So for the 2.5 in this expression, it's different. Yeah.
When you put in 5.5, you sure you got positive 28?
Positive what?
28.
For which one of them?
When you put in 5.5 for section BC.
Let's check that again. There's minus 26 times what? 5.5? Let's check it. Let's check and see what we get. We get minus 143, don't?
Yeah.
Add to 115. What do we get now? Oh, we're getting minus 20. Oh, we get a minus value. Let me just check that. Let me just check the analysis of that. All right. So 1 second. So yeah. So we get minus. It was not positive, it was minus. Thank you for that. All right. So where we are. So it means therefore, just like before. All right. So that part was positive 28 for up here. No, what hold on. You said we give us minus 28. Hold on. Minus 28. Why did it give us minus 28? I'm not certain why it will be that we're giving us minus 28, because at this point, where's 5.5? 5.5 is right here. And we should be above 0 right there. So I'm just checking that value. Minus 26x plus 115. And I don't think we have any sign, any wrong sign. Let me just check our sign. Our sign seems to be okay. Let me just double check this, the transposition here. So it's minus 46. X minus this. When you expand it, we'll got minus 46x plus 115 plus that. When you transpose, you know, something seemed to be off. When we transpose, this is supposed to become positive. Yeah, there was a sign, something is wrong there now. This is positive. And then, no, hold on, let me just double check that. Let me just check back this formula. So when we have it, you have m minus 46x plus 115 plus that equals to 0, correct? So m now should be equals to 46x. Sorry, is that correct? 20 from that would have given a minus, so you get positive 26. Right? If you're carried over, it becomes positive 26 and it's become minus 115. Right, so something was incorrect. Let me clean it up. Something was incorrect while I was getting the signs changed. The signs were not supposed to be changing. I was wondering why. So apparently in my transposition, what was the value here again? 26? Positive 26. Everybody agree with that now? So there's a slight change. The sign changes up here. I realized that there was an error and I couldn't pick it up. Let me just clean it up. So that's that. So the sign changes. So let's analyze it again. See, oh, this was what? Plus, and that is minus, right? All right, let's go through that again and check it. So when this goes in, we should be getting what? Minus 50 and not positive 50. So we should be getting the signs flipping around. This is supposed to be minus 50 and this is supposed to be positive 50. Let's check that again. So it is 26 times 2.5. You get here 65 minus 115. So you get minus 50. So right, so you get back the value here. So something seemed to, that was this, the sign was off. So that's minus. When you put in 5.5, you should get positive 28 right here. So you should get positive 28. And likewise, when you put in this, you should get positive. When you put in 5.5 in this expression, you should get positive 28. Let me check that. So when x is equals to 5.5, m is equals to 105 minus 14, 5.5. And that gives us what? 105 minus, how much is 14 times 5.5? 77. And that equals, the difference in that is what now? That is positive 28. Right, so you get positive 28. So we are saying when this is 5.5, which is right here, so you get a positive 28. When this is here, which is what, 7.5, you get what, 0. So yeah, so that's how it should really work. So the expression should give you back the values at the starting points for each one of them. It wasn't working out that much. It means that a sign up here was incorrect. All right, so you have to check your working. But one of the things that told me that something was off is that when I work these areas here and I do the little checks here, I can know whether or not I'm on track because I would multiply minus 20 times 2.5. How much you'll get for that one? So minus 20. So another way of checking it is you get minus 50. So you know that right here is supposed to be minus 50. When you come here and this is what now? 3 times 26. How much is 3 times 26? That is positive 78. All right. So you're going to add positive 78 to minus 50. And you're going to get 28 right here. So that's all you'll keep it and check. What about the last part? The last part would have been minus 14 times 2. So you get minus 28. So positive 28 plus or minus 28 must take you back to 0. So that's all you can check to see if you're on the right path, right? And so this was a full exercise wherein we actually went and worked the problem from start, forming the equations. Remember now, we started out, we found the reactions at B and D. Then we said method of section, we section between A and B right here, right? And you had the reaction here, this force that is a point load here, and this other is AB. So it's only this section that we consider. So see it over here. So we have the 20 coming down. This here, wherever you cut it, there's a shear force there and there's a bending moment. And the only distance is considered as X here. So it was easy to do the shear force equation because we just say the sum of the Y minus 20 minus 4, V equal to 0. So V is equal to minus 20. What about the bending moment? So the bending moment was between AB. So the bending moment, this was positive already, so you can write it back. And then you go, now you're gonna take moment here. You notice that this is what? Positive, because it's 20, which is going down, so it's going to give you an anti-clockwise moment. So it's 20 times X. So it's 20 times X right here. So right? When you transpose for M, you're going to get minus 20x. From this, it's showing that the shear force is going down. So you know the bending moment is supporting that. For section B, when we cut it right along here, you will have to consider how many forces you have at that point. Right where we are cutting plane line is we have V, of a bending moment, but also we have one force coming up and one going down. So we have the reaction and we have that. Two more forces increase. So are we taking moment right here? So the first thing we do, we're gonna use your sum of your equilibrium equation, sum of Y equal to 0. So that is minus, this one is plus, so see it, and the one coming down is minus. So it's minus 20 minus V, because you have two minus force, plus 40 that is coming up. You transpose so that you will get 26 kilonewtons, all right, for your shear force at that point. For the bending moment part, which is between what now? BC, we have to take moment for the different section. So we're gonna take moment for that part, we take moment for the 20 force, the 46, right? And we consider that we have one here that is always positive. So it's start out with this. So it's moment here minus 46 times this. Now you're taking, you want this little distance, but you know that over here is 2.5. But the entire distance, this distance is greater than 2.5. That X is considered greater than 2.5. So it must be X minus 2 for that little section. You take the moment, this moment is going in the clockwise, so it's minus 46 times X minus 2, bracket, plus 20 times X, which is in a positive direction in the anti-clock. So it's, you get that 20X equal to 0. Now, as we said here, we did a little transposition that was incorrect. So you transpose that, you should get positive 26x minus 115. All right, so that was it. You had a sign problem right here. For the section CD, which is this section, we are going to cut it somewhere in the middle. You don't cut it at the end, please. Cut it in the middle. So it means that you're going to have three forces, four actually forces there. So we have the shear force. Wherever you cut it, you have a shear force. You have a point load 40, you have 120, and you have a reaction. So it's four forces you have. So let's go. So you have a positive 40, you have a minus shear force, which is V, minus 20, minus 40. So that gives you a minus 14 kilonewtons. What about the moment now, which is a little bit more tricky? So the moment you have here, which is positive, first one over here, then we're going to take moment now. For the 40 moment, you have all of this is what? 5.5 up to here. From A to C is 5.5. So therefore, this distance must be, if from A down to here is X, it must be X minus 5.5 to that point. So therefore, it is 46. This will like 40. It's 46 people. Was it 40? Oh, yeah, this is 40. Is it confusing me? No, it's 46 now. So it's 40 up here. See that 40 there coming down? It's coming into the, which direction is that? It's coming into the anti-clockwise. So it's 40 times X minus 5.5 bracket minus now. Where's the 46? 46 is going up in the clockwise. But what is this distant? Is distant is now going to be X minus 2.5. It's not 5.5 again, it's less because it's only this section here is not accounted for. So it's X minus this. So it's this section. So the distance between here to down here must be X minus 2.5 because this is 2.5. So it's 2.5 minus X for the 40, and this is minus. Then now the last one, 20 times X. Remember we started out with 20 times X. We started out with this. And then the second one was this one. So we had to add it. And then the last one was the 40 minus 5.5. If you notice what I'm saying here, your first bending moment including 20 minus X here. The second one was this. Right? It's the same expression there in the second one. See, come back here. And then the last one have this expression that is added to the, so you add the first section AB, BC was this piece, and then this one. That's how it works. You have to continually add back those expressions that you had before, but you would do it in a systematic way from once you take moment, right? So you probably don't notice it, but the first one was what? 20x. Where is it? See there? It was 20x. It coming back into the moment. See there? It coming back in. And let me just say, so, and it is positive here because it is going down in the anti-clockwise direction. This one likewise is 46 times X minus 2.5. And see there, it was 46 times X minus 2.5. See there, same thing, it's come back into the last expression. So each expression is gonna add back to the other moment expression coming down, if you understand what I'm saying. Right? And then the last one, which is now an addition to the problem, this 40 here, which is not involved yet for moment, going to be 40 times X minus 5.5. So when you work out that, you get one final expression, which is 105 minus 14x. Some people write minus 14x plus 105. Nothing wrong with that. I just neat it up mathematically for you there. So that was what we get for the first one, minus 20x. The second was that is add back into this one. So this expression is a combination of that one and this. It's really a combination of them, right? To give you a final answer like this. And we look at the range. So that is how we approach that problem. Any question? Everybody all right now with that one?
The moment diagram, moment graph, it kind of look funny. I'm not really understand the moment graph.
All right, so remember now, this is a positive moment. Up here says a positive section, positive moment, and this is bending moment. Here, people, I might not be using the term too often. So the first one, if I ask for shear force, that is SF donated, this one is BM. So we may use that abbreviation sometime. And if we ask for the positive, the maximum, we're not ask for the maximum shear force. What is the maximum shear force here? It is 26 kilonewton. See it up here? And the maximum BM is 28. And this is what? This is what? Newton meter. All right? So BM is Newton meter, that's a unit. And for shear force, it is newtons. All right? So just the same thing. So that's force. This is really essentially is a force. And this is really a moment. So I don't understand what you don't understand, Scott.
All right. You said the point and the zero. on the x-axis.
For which one of them? For the bending moment?
Yeah, for the bending moment. That point look like it wouldn't be one of the values that we plug in.
Which one of them? The minus 50?
No, the 50, when it comes up back to 50.
All right, let's go through it again. Look where the AB is. All right, AB, this was minus 20. Oh, that's not the shear force, the bending moment. So it's minus 20x. Minus 20x started between 0 and 2.5. So when it is 0, you know, so it's right here. When it is 2.5, that gave us what? 50. So it's minus 50 because this is minus. So it tell you that it's coming down here, and they tell you that it's a slope, so it must be straight line coming somewhere down here. And it's below 0. Right? Some people don't believe their bending moment can be below 0, but it can. In this case, you see that it's certainly below 0. So it come down here. So you see, right, look, up here, what we do, we always put our original frame first, shear force second, bending moment last, because it helps us to approximate the distance without actually have to draw anything to scale. It gives you an approximation, this distance across. That's what is important, why we put it underneath each other. So if you do it in exam, you must do it in this order so that I can easily understand what is it that you're doing. You don't do shear force one section and do bending moment another section. You draw your, whether or not you want to use that one or this one, more likely you're gonna use your free body diagram here, not this one, but you put your free body diagram right here, right? And then you do the shear force here, bending moment. So you start with that one, 0, and then at 2.5, see there, this line is representing, can you see my thing here? 2.5 right here. All right, I don't have another pointer. Do I have another one? I'm not seeing any big bold pointer. You're probably not going to even see that better. I don't have any big bold pointer that you can see. Right, so right along here is 2.5. So this is telling you where your minus 50 stop. All right, so when at this point, when we take up for the next equation, it should start us here. So for the next one, which is what? BC. When we correct our formula, when we substitute in for x at 2.5, it gives us back our what? Minus 50. So we start back here. And then the last one should start us here. The range here. 5.5 into that, it gives us 28. So positive 28 is right here. So for each one of them, tell you where to start. And then the last one, you drop in back the value at 5.5, you should get back that value. And then you put in 7.5, you should go to 0. Right? Anything except that is 0. So you have to check the formula and make sure that they are correct at all times. All right? But as I said to you, the check that you can use to know if you're on track. And if I tell you to use method of section, I expect to see my expressions and I will mark you appropriately for expression. If you use the area underneath your shear force to get the bending moment without, and I tell you to use method of section, then you will be penalized. If you are just told to do it without being specific, I couldn't really penalize you, right? But it is good to know the method of section. So but the method of section help you to do a balance, but you have
the point after you pass 2.5 on the
yeah, right here. So this is 2.5, and over here, so this is 3.
The next point on the axis itself. After you pass that point,
down
right?
Here, so? Right here, so?
Right here, right there.
Yeah.
Which point of x is that?
Which point is what?
X. Which x value is that right there?
Well, it crosses 0 there. That's what it tells us that it crosses 0. That's a very, very, very good question. Right? One thing I can tell you is that it crosses 0 there. That's what I can tell you. Right? That's what, and we know that based on what, and we know, but one thing we know about the bending moment is always a slope. So if you're starting here, you're going up, you're going to get a slope line going up. If you get 28, it means that somewhere along that line it crosses 0. Right? But if you know, in our expression, we don't have no zero in it. It is between 2.5 to 5.5, you know, as far as we concerned. So we know say come back to this point here, but remember, you know what I gotta tell you this? This has a value, you know, where it crosses it, you know. You know that there's a value there. And you see, if this was drawn properly, let's see if I can take up a head. If this was drawn appropriately, you know the value, you know. You could know that you could map back that value up to it, that it's supposed to be somewhere between all right, that's like a 3/4 of 3, that is 1. That's all. So that means that is about 4.5. Let's put in 4.5 just as a check. And which expression should we use? We're gonna use BC. Put in 4.5 and tell me what we get. See if we get close to 0. So that is 26 minus 26, I should say, and I'm estimating it, and I'm putting 4.5. So I figure that I'm almost correct. My value is close. I get -2. I should get 0. So it means there, so there is a value there. Very, very important question. There is a value there that will give you it will give you 0 at this point. We have mathematician in the class, they can find that value there. All right. I don't know the value that it is correct. I estimated a while ago. It tell me that I'm about 2 digits out. So I don't know. I'm 2 digits out in terms of when I finish calculating. I get, so you're adding minus 117 to plus 115, you get -2. It means that I'm 2 digits out. So that means I'm very close to my, and let's say this is an estimate. So I estimated that this, so probably it's either a little bit above or it's a little bit below, right? Wherever the value that the x value. So the x value, remember now, you know, the x gonna have value. I estimated the value a while ago, but it doesn't necessarily mean that I am correct, as I tell you. Let me see. Let's go again. So it doesn't reach 5. We know the value don't reach 5. So, and it's below, so it's below 5.5, that will actually,
yeah, value 4.423 there about.
yes, so it's somewhere there, but so it's somewhere across the x-axis, we know it. That is not within our range, you know. Our range of plotting value is different. If you notice that, our range of plotting values, right, is pretty much different. We would have to use the section BC. Well, yeah, actually it's the section BC. The section BC, how much, oh, you say it is what? 4 point? 4 point, what you said?
4.23.
4.23. Yeah, so somewhere there is that value rate crosses 0. So, right. But you would have to be able to map that. So I mean, that's a question that could be asked, but more look like a little mathematical question more than shear force and bending moment. That getting into maths. So you would have to go do a little bit of calculation. I suppose you could find it because well, I don't know the length of the slope. All I do, I know that it is -50 at that point. I don't have much other information. And it crosses 0 at that point. You understand me? So that would be some little mathematical thing, but that to me is not part of it. Wow, I'm not hearing you at all. Your internet giving a little some issues there a while ago. Couldn't get you clear at all. Anybody heard what he said? Anybody? Anybody can figure out what he was saying? You want to try and repeat again, Tommy Scott?
No, I was saying that at that point moment would equal to 0. So they would just substitute 0 for moment there and the transpose x.
Oh yeah, you say moment and you'd make a okay. So you say the expression, you will put it to 0 at that point. Yeah, the same 26x minus 115, you will put it to 0 there. All right, fair. Right, right. Excellent, excellent. So yes, that's like a mathematical thing there. Yeah, if you analyze, you just put the expression 26x minus 115 equal to 0. And you're from there, you divide 26 by 115 and you'll get that value, don't? And that give you the 4.2, whatever it is. All right, fine. So that you can, yeah, so you can work it out that way. And that is getting a little bit mathematical. All right. On the other part is so that kind of clarified for you, right? You're all right now. That you
Yes, sir.
have
Yes,
actually
sir.
reasoned through. Yeah, man. So it's very practical. Very practical. So it's moment going right across. At that point it's 0. So you could go through it like a mathematical way there. All right. All right. So that is that for that problem. Now remember in the slide that I gave you, and everybody should have it on Moodle, right? That everybody get some question to work out. Everybody know their questions now? Most person know their question. I'm asking now. I think I'm asking a valid question.
No, sir.
You're at class yesterday, Rod, don't?
No, but group C didn't get a question.
Group C didn't get a question. All right, so that
Oh,
means I need to find a question for Group C right now. Hold on, let me see if I can take one out of my hat. Right now, hold on. Let me see if I can find a suitable question for Group C. Whoa. Whoa. Group C. Whoa, what a question. Oh, my. Hold on, Group C. Because we need to give her a question right now. Let me look back at the question that we have in the slide. Hold on, let me open that slide. It was at the shear force slide now. Hold on, I'm trying to find your file. It's a PDF. Hold on. Shear force. All right, for some strange reason, that file not giving me problem to open. Hold on, let me see if I can get it to open again. Shear force. Okay. All right. Let me stop and share what I'm opening it again. So let me just share it and see if we can refresh ourselves on the questions. Right? I want the class to participate and I can just have you sitting down. So this is for Group D. Right? And I work out the reactions already. So you don't have to worry about it. That part is done. Right? That's Group D. And then now I gave this question to this was Group A. And Group B was
Sir.
Yes.
I just assume past that. You can go back to D question.
To where?
D question, D.
Yeah.
Group D.
Yeah. Here's your question. So you get all of the values already. I didn't even give a problem to work out the reactions. I do that and show you what's that. All you need to do, come up with this section that you can do a method of section, and you're gonna sketch your shear force and your bending moment, and it is gonna mark on the classwork, right? So this is classwork. I have the grades for the classwork. I soon drop them in. I'm thinking about penalizing persons who didn't participate and were not at the class, because obviously I can't give you a grade that you didn't participate for, if whether or not you're in the group, and that is a challenge.
Sir.
Yeah.
remember some people might have had technical difficulties while they didn't attend.
That is true. That is true. I'll consider all of that. All right. I'll consider all of that. All right. So that is your question, Brandon. That's your group one. This is A. So you have your distant. It's actually showing you where to cut them already. So it's all right. So it's just giving you a cutting plane line. You know, you cut it 3 times. So we're giving you all of that. So you're gonna draw the free body diagram, find the reaction, draw the shear force and the bending moment diagram, and state the maximum shear force bending moment. So that's another question for that group. Now, you know, Brandon, is you're gonna follow the first same pattern here. We do one part for you already. So you do all except the same thing. You see this question here. Come on. I find part B already for you. I have to do the reaction. So you're going to draw your free body diagram, which I partially do for you already too. And you're going to do your shear force and bending moment diagram and state the maximum body. That is the biggest part for you. And then now, the last group B, right? So group B, this is your question, which is a nice question. As a UDL on it, and you see the distant, right? So I need to find a question for the other group that is there. Need to find a question. I'm looking for a question for you right now because I've seen that we are here. Delay is danger. So let me see if I can just find one for you because everybody need to participate. You need to find questions, you need to read and you need to work them, right? Everybody remember that they're having a test this weekend. This weekend I'm gonna set up what would I say, equivalent force and frameworks. So both method of section and method of joints, you can get both, right? And you get equivalent forces. Next week, you can get shear force, right? And that's how I've been doing it going down the line.
What's the format for the upcoming test for this weekend? The same multiple choice?
Same thing. It could be that I find out that I may need you to write. So I could mix it up a little bit. I need to just play around with Moodle. I'm not really too good with Moodle in terms of the putting on questions. I'm just feeling out the site. The last time I used Edmundo, so it's a first time for me. So I'm still feeling out the site. So I'll see how flexible it is. It wasn't so bad. It's actually better than Moodle in terms of putting on multiple choice. Because I had a challenge on Moodle, so on Edmundo, and that has been wiped. That's gone from Moodle. So I give Moodle thumbs up for that. You know, I had a problem with diagrams, and this one just take diagrams and everything. You know, same time. So it's a big improvement. All right, let me see if I can quickly find one while I'm jumping through these slides here. If I can find one for this group. Everybody need to have one that is simple one. And by the way, not all UDL are necessarily flat. I didn't get time to go into those, but at some point I'm going to have to turn up the notch in terms of teaching shear force. I'm gonna have to start to look at the ones that are not necessarily a rectangle. All right. I won't get into that one for this group. Let's try and see if I can grab another question for you. And please remember that you all need to start that bridge project.
Sir.
Yes.
It's actually question 5A for group B.
Question what?
5A and not 5B.
is actually question, what you say?
5A.
Mm-hmm.
You actually assigned that one to group B.
Mm-hmm.
But a while ago you said this one was for group B.
Hold on.
No, he said it was for group D, not B.
B.
Now the very first question I gave it to group D. But remember that? The very first question.
Right.
Mm-hmm. So you're saying that I did so I'm saying the opposite now?
So question 5A,
Mm-hmm.
you actually assigned that one to group B.
It wasn't group A?
No, B.
Mm-hmm. Really? Oh. Mm-hmm. I mean, times those are possibilities. I just didn't remember doing such. All right. I think I see another little one. Let me see if you can manage this one. All right. Let me see. I think I see another question, but I'm trying to pass it over to you. All right. All right. I have another question, but let me see if I can bring it across. By the way, we are going to do a new. We have to do. We're starting a new topic this evening. So even though you said I'm moving a little slow, we intend to, and it's a revision for you. I hope. So we're doing a new topic this evening. We go well, it's not new to you. It's centroid, right? And you all should understand centroid pretty well. So it shouldn't be anything that you can't manage per se. All right. So that's a nice little question, you know. All right, let's see if I can bring this question across. Or am I gonna get it across? All right. All right. Let me just try and drop it on the slide and see if it works. All right. So I'm going to try and drop it in here. Let me see if I can do it here. So it would save time. See if it comes across. Beautiful. So this is your question. All right. This is group, and this I can just this is let's write them down. This is group C. All right. This one now is group this was group what was this again? This group A, correct? Was this group A? What is that? This one is group A1. This is what who said that I gave this to group B? This is where group A, which one was yours? The second one? Which one was yours, group A?
That was that.
This is
Not this, the other one, sir.
this was what? Hold on. Hold on.
That was group
This was
C, sir.
That is group A.
This is group A. I know this is group A. Yeah, this is group A, right? And then this one here was group B, correct? So that's group B. So let me see if I have them right now. I can label them. Yeah, how do you get this one? I'll have to send it to you separate again. I'll probably have to go send it separate to you because hold on. So this one is group. Let me just document it. This is group D. All right. So group D, that's yours. Oh, you didn't save? What? Yeah, it's save on this page. All right. So, right. So this is group D. All right. And group A, group B, and this is group C. You can actually delete this one. Delete. Oh, hold on. What's going on now? Oh, well, didn't go. Delete slide. All right, cool. Right. So that's this group. This is now group C. All right. You want to draw it down for me? So everybody, group C, I think you should take it down. So it's a UDL. You have a point load at C, and it is from A to C is 5 meters. The UDL itself is 25 kilonewtons per meter. Separate. So the UDL right across is 25 kilometer. So if you need to know the effect of it up to a point, you're gonna multiply the length of it times that. All right. And then you have a point load out at the D separately. So you must try and come up with your graph of it. All right. And what you can do, you can take off the load, work the problem without the load, draw it, sketch it up, analyze, understand it, and then you put it on the UDL and you try and separate. So those persons, you can do it that way. So when you get the UDL part, you can realize what is the change. So you can split up the problem in 2 parts. Take off the UDL off it, just keep the point loads, all right? You work it out. Put the UDL back, work it out so you're able to see the difference. Right? And you can actually share it with each other and have the discussion, right? And that will help you with your learning. By the way, you need to go to the chapters and look at the basic ones, because I'm just giving you one to come to class and explain. It means that person must be going in the text. I probably need to give you some more questions. I probably need to look for a bank of questions and drop them. So I'll try and to look for a worksheet, to drop a worksheet so you actually work the worksheet so you can do the question and participate well. So that's another consideration. All right. So somebody please, you can screenshot it if you want, and you have the, so I'll make it bold. So you can screenshot it. There you go. Screenshot it, save it. All right, that's good enough. Group C. Group
Yes,
C,
yes,
please
sir.
screenshot it. I'm gonna do the same to the others, and you scream. Well, you have the others. You have the others. It's only group C wouldn't have had this, because this is in this slide. You can double check. This is in the slide on Moodle, except this question. All right. So this one, this should be in the slide. Pretty simple. And that one. This is just 2-point load. So you get this one easy again. And this one now might be the most challenging. Might be the most challenging. Group D, I give you the reactions. All you need to do is sketch. You just need to do the shear force and bend the moment and give you maximum value. So I have reduced the level, and you actually show your working, so you don't have nothing to worry about. I show you how you get it, so you can use it now to understand how you get the moment. Ignore this piece around here for me. I was going into another zone, but I didn't bother with that. Another type of formula, singularity I was going into. So you and this one is pretty simple. You're gonna take this from, so your free body, this is almost similar to the free body, but you draw your own free body, find the reactions at A and B, right? Simple, and you draw the shear force bending moment. And now you must come to the class and make sure everybody understand what you're doing, because everybody coming to explain it, and everybody need to jump in and know what they're doing. All right. And likewise, this one, you have a UDL here. The UDL is 15 kilonewtons per meter. And over its span, how to find the convert it to a point load is by multiplying the distance. So I'm telling you that. You're gonna find the reaction here, with those. So it's pretty much determine the reaction at AB and the overarm subject to the loading. You're gonna draw the shear force bending moment. You're gonna draw your free body too, which is automatic. Identify value of the shear force at B, right? And the maximum value of the bending moment. All right. So you can identify maximum and minimum bending moment, maximum shear force, sorry, and maximum bending moment. There's minimum to, but the maximum is what is important to me. All right. So those are your class work that you're coming to discuss in the class. But the group need to come out of its shell, all right, and start talking some more and talk around the question so that we feel that everybody is on the same page. All right. So that is that. The time now. What time is it now? It's almost 7 o'clock. So we have been chatting for. I have been talking from about, call it 5:30 to now. All right, and we have another hour and a half to go. All right. So we're going to do two things, but I'm going to take a little break and give you a chance to catch your breath too, and then we will move on to let me see. I should have it open here. Let me see if I can. Hold on. I'm closing out some of them. Oh, I think I'm mistakenly close your slide. Trying to find it again. All right, I'm going to try and find out the slide. It's accidentally close it. Let's try and find it back. All right, let's go again. Centroid. Oh, well, I think I have it back. Let's see if I can share it so you know where we are now. All right, here we are. So this is where we'll be starting. All right, and we will go basic, and we just talk around it. So we're gonna find the centroid of. Come on, we're gonna find the centroid of basic figures, what we call compound figures and regular figures. So you're gonna regular, uniform shape and composite figures. But we're starting right there, which is very basic for your physics class. I'll leave that there so you know where we're going. All right. So everybody can take a break. All right, I trust that you are ready and rearing to go now. All right, I see that most persons have registered. Eh? All right. All right. So, center of gravity, which is really the central, eh? Center of gravity of a body is a point at which the whole weight of the body may assume to be concentrated. So a body having only one center of gravity for all positions of the body, represented by CG or simple G or C, right? Is a center, right? All right, so similarly from your O-level physics, you know that if you hang a body at a point, you could actually draw a straight line, eh? So if you have a body and you hang it at, let's say you have 3 points on it, A, B, and C, and you were to run a line, you hang it and make it at A, and you draw a line, so you get a straight line there. You similarly, you hang it at B, and similar at C. All of those straight lines will intersect the point. And where those intersect would be your center, right? And of course, that would be the center of it, right? So, and you could also call them a what? Collinear chord, right? And that simply can help you to find your center of mass. So you can find center of mass, center of volume, and all of those stuff, right? And because this is really a mathematical concept, it also will help us into principle of moment in terms of the gravitational force. So another way of looking at it is the center of gravity is that point about which the summation of the first moment of weight of an element of a body is 0. All right. So in this topic, we will also, it will help us to talk about inertia, or what we call the second moment of era, right? But first we need to know how to find the center of regular figures and what we call composite. So these are regular figures, right? And likewise, we have I-beams, and you can find the centroid of the I-beam, right? Some of them are symmetrical. Like for example, the one that we're looking at right now, it is pretty symmetrical. C lies on the axis of symmetry. Can you see it right there? So this is the x-axis, and it lies there. This is also the y-axis, and it lies on the axis of symmetry. So this is a symmetrical figure, right? If you look at the bottom one, where all the y and x-axis meet, so the axis of symmetry. So we'll be looking at I-beams too, T-beams, right? So for example, this one here, this is an I-beam. So this figure says find the center of the I-beam shown to the x-axis. Now there's also something that we call the neutral axis, NA, which lies at the point of the centroid, right? So let's just quickly look at this one. This is what we call a high beam. So up the top is 100 for the what you call that length, and then the height is 20, and then this section underneath it here is 20 is the thickness. So the overall uniform thickness is 20. The height between here is 100 millimeter, and this of course is 20 again. So the complete height is 140. And it can be symmetrical because it's balanced, right? So we can find the centroid to see where the axis of symmetry lies. Now, as you know, it can be done in two different formats. We can use a simple formula, right? So the coordinate centroid surface area about the axis can be calculated by using the equation. Meaning the equation which says the entire area of the body times y prime, which is telling you that that is the centroid point that you want to find, times the area of the first section times the distant y1, the area of the second section times the distant y2, and so forth. If you use this formula essentially, and this formula utilize the first moment of area. So this formula is a formula that utilizes a moment approach, right? Which is equal to the algebraic sum of the moment of the element of the about the same axis. Now, you may have seen something like this before, but you don't realize what is happening. So we're gonna just look through it quickly. So I had worked out this one some time back, and they said this is I-beam. I know that some of you have done this before, right? How many of you have done this before? Can somebody please talk to me? Have you done this before?
Yes, sir. Look familiar.
Look familiar. All right, nice. Anyway, I will go through it to ensure that everybody understands the concept. And for those persons who didn't understand it before, hopefully you will understand it now. So the area of a section A, so what we did, the IB, we separated it into 3 sections. So the first section, I call it A, meaning that all of up here I call that A. All of from here down to here, I call that B. And this section, which is similar to A, I call that C. So the first area is going to be 100 times 20. So that gives me 2,000. The second one is 100 times 20. Another 2,000. And the third part is similar. So all of them have basically the same area. So this one is pretty much a straightforward one. And it's an easy one to explain. All right, but not all of them are this simple because you don't necessarily I-beam, they don't necessarily have the equal, the parts are equal. Can be any size. Understand me? All right, so those are the areas. In this case, pretty much, so 6,000 is the total area of this I-beam. Now we're going to use the first moment formula. So it says the area time the area of the figure times y prime. Now y prime is going to be the distance from some, and it depends on where you find it from, you know. So let me just clarify some things here. We said that you have to find it showing so you find the centroid of I-beam shown to the x-axis. So it means that we're working from the x-axis to find it, which is very important. We can't just find something without knowing where we find it from. So we're finding it from the x-axis in respect. So some distance up here, we're gonna call it. Let me show you where is y bar. It's not there, so I need to highlight it. Hold on, trying to get back my slide. What's going on here? All right, let me see if I can write it in, draw it in. So y bar It's going to be some distance. Oh, this is y, and this is x, as you can see. So somewhere up here from the base of this, something shift a little bit. It's supposed to be, it's supposed to, the frame, it's supposed to really sitting down on the frame. So let me see if I can fix that. Let me see if I can fix that. So the frame is not, let's see if I can fix that. So it's really resting on like that. All right, and that's the real truth. That's how it's supposed to really look. So anyhow, so that being the case, and that's important, a very significant thing, because I don't want you to misunderstand the concept. So this is your 0, this is x, and this is y. Now, so you know that your y, maximum y is 140 up here. We want to find some distance to recall to the center. All right, and this distance up here, we're gonna call it y bar. And you're reading it from the x-axis. So you find the center in respect to the bottom of the beam. So down here is the bottom, and it's down here you're going to be looking on as you take the measurements. So this formula is saying AT times y bar is equal to the first area times y1 plus the second area A2 times y2 and so forth. So let's look. So the first one we know is a given. So it's the total area of the beam times this distance here. All right. What about the second one? So the second one is going to be AR1 times 130. So the first area is 2000, right? Now, the height of this first area to its y1 is going to be from here. So your y1 is going to be to the center of this one here. Reading from your x-axis. So that is your y1. So in this case, this is 20. So this is automatically 10 here. From here up to here is 10, plus from here down to the bottom. So you're going to be 100 plus 20 plus 10. So you get 130. But you understand that? Who don't understand what I said a while ago? Everybody good? All right. Nobody else said them want to. So it's to the center. All right. So that is giving you a y1. So it's the area. So it's y1 times the entire area is that first moment. The second, the next moment for this piece here now, this from, so the center of this is how much? From ear to ear is what? 100. So 50 is halfway. So it's going to be 50 plus what? The 20. So that gives you what? 70. Because this is 100, so halfway 100 is 50, plus the distance from this point here down here is 20. So that is 20. So this is, so wherever that drop, that would be giving you your y2. So it's halfway it, going right down from where halfway is, go straight down to the bottom is y2. And y3 is half of this guy here. So it's 20, so half of 20 is 10. So that's why you get 2000 times A2, 2000 times 10, because that is A3 times that. And then now you transpose y bar. So all the areas worked out and you divide it by the 6000, the total area. And that gives you 70. So we are saying when it is 70, 70 is going to run halfway because the total height is 140. So 140 says half of 140 in this case. So it seems very symmetrical structure. So it's one, so this is 140, this is 70 probably. All right. So y bar is 70. What is x bar? Can somebody tell me what is x bar? If y bar is that, what is x bar? Can I find x bar too? let's suppose I'd ask you to find X bar. What is, if it has a Y bar component, do it always have an X bar? That's the question I'm asking, and I'm waiting for an answer. And if it have an X bar, what is the value? Hello? Anybody there? Anybody there?
That's a 0, so
What?
that's X bar equals 0.
Really? Mhm.
That's the 50, Mr. Broom.
So, hold on, man. Let me talk the road a little more. Road, why you don't say L0? Think about it. If Y bar is 70, how come X bar will read 0? Think about it. Remember, I know. The coordinate system we're talking about. So, you have, so if you have a coordinate, you're going to have a X component and a Y component. That's true. So if you have an X bar and you have a Y bar, it must have a, it must read 2. So wherever Y bar is, there must be an X bar component. That's true. And that is the central point. So when Y bar is 70, you know that this is, all right. Let's suppose in fact, your Y, see guys, your Y should really touch over here. You see the frame, it should really touch over here. I think it still needed to be fixed. I didn't fix it properly. So in other words, you see where this line really run is where your Y really is. So the arrow, it should have been resting here rather than join over. It's really right there. So read it off from there. So that's really where your 0 is. All right. So ignore the other part of the front. So your Y bar is here. What would be your X bar? So it would have a corresponding X bar wherever Y bar is. So when it is 70, what is X bar? So X bar must be, because when you center of this, it's going to be what? 50. So it must be 50 at that point. So it is at 50 when Y bar. So this is X bars. And if you work it out mathematically, it's the same thing. Meaning that you know that just like how you find Y bar, you could find X bar too, you know. What would X bar be equal to? So the question I'm going to, let me drop this, and I want you to answer that question. Could you use calculation, guys, to prove it that X bar is 50? So in other words, this should be really right here. Can you use calculation to prove that X bar is 50? That's the question I'm asking. I'm asking a question, guys.
Yes, sir.
I repeat that question, please.
Saying to you, just like how you find Y bar, can I use calculation to find X bar and prove that X bar is equal to 50? Can we calculate it and prove it? Could we use calculation and prove same? That is what I'm asking.
Yes, sir, you could.
All right. The fact that is the same, I want somebody to tell me how to do it using the same figure. All right, and I'm going to fix it up neatly in OneNote, and somebody is going to explain to me. Oh boy, I've been trying to draw the diagram around here, but hold on. I have it a copy, but I'm trying to put in some stuff here so that persons can understand it. Give me a second. Oh, come on. Let's see if I can draw it a little bit better now. See if I do a little bit better than the first time approach. That is Y. That is X. So we're going to prove this now. So let me stop share and start again. All right, here we are. Okay. So what I want, we know that we're gonna still use the area that we have. So this is A, this is B, and this is C. So all right. So we know area 1 is 2000. Those won't change. B area is what we call them. So A1, A2 are and calling A1, A2, A3. So each one of them is 2000. All right? Each one is 2000. So we know those. I'm just trying to make sure that how I label them is consistent. Let's fix up that. I think the writing with the pen style wasn't too attractive there at all. Let's just get going there again. What's happening here? Come on. Don't like when this thing do this to me. No. Hold on. What's going on here? Hang on a second. Come again. All right. All right. All of a sudden this thing just get very small. What is that? All right. Can you see it, please? Are you with me? Still? Are you seeing a figure?
Yes, sir. Yes.
All right. So this is A1, A2, which is representing B. This is representing A, area A. This is representing C, which is area 3. So this is 2000. This is 2000. All right. We need to prove that, 1 second. We need to prove that X bar is equal to 50. We know that Y bar is equal to 70. So what it means, therefore, is a like a switch of orientation. Now we're going to find X bar from the Y-axis. So it is a reverse, a significant reverse. So we're going to look at the Y-axis, the relationship for each area from the Y-axis in order to find the X bar. So we're going to try it that way using the second moment formula. So this time around, the formula would have been area total times Y bar equals to what now? Area 1 times
50.
X1 times area 2 times X2 plus area 3. Somebody said something? Hello? Someone said something?
No, sir. No, sir.
Sure.
Let's write out the formula with you.
All right. So this is so I switch to the formula now. The formula is going to switch. So we're saying X bar, at the end of the day, your X bar is going to be equals to total A1 X1 plus A2 times X2 plus A3 X3 upon area total, which is consistent. So this time around, we're going to have to look for different measurements, but we're reading it from this direction now. So everything is relating from the Y-axis, not the X-axis this time. Because X bar is actually this way. So X bar is this way. Some line running through here is X bar. So if it's not symmetrical, in this case it is symmetrical, we can look at it, but I know it. But suppose it's not symmetrical, you should be able to calculate it just the same, right? You could use a table, and I'll show you how to use a table. I'll remind you how to use a table for composite figure, but we don't reach here, so let's go to this one first. So we have A total, which is A total, everybody knows 6,000. So that's our given. So let's go. So it is 6,000 times X bar. Now, what is A1? We know that, 2,000. What is X1? x1 is going to be some distance x. So the distance x going to here, with the center of it from y is going to be what? 50. Not true?
50.
Plus 2000
Them are 50.
for A2 times x2. What is x2 from here? X2 from here is what? We know that the thickness of this is what? Is 20.
20.
But what is the distance to the center? To the center of that, what is that distance? Anybody can tell me?
50.
Is it still 50? That's the question.
Yes, sir. 50, sir.
50? You agree that it is 50? But hold on. What's the thickness of it?
20.
Thickness of it is 20. But to the center, is it still 50?
It's the 20 millimeter part.
No, I'm just asking you. It's thickness. In this case, its thickness is
Attend, sir.
Hello? Someone said something a while ago?
I said 10.
10. Why would we want to think that it is 10? Why do we want to think that it is 10? Why don't we say that it is still 50? Huh?
So I understand. Because I mean, if I the 20 millimeter part we are talking about, half of that almost 10. And if I the 100, half of it almost 50. So see. Yeah.
But no, the question is to you, where is the center of that figure in relation to the y-axis? That is a question really, you know. Is it still 50?
Yeah. Half 150.
Yes, sir.
So you're saying, let me see if I get you right. Talk to me again.
Sir, but if on the x-axis we are working, we will just work the 50 on the x-axis.
Come again, I didn't get you.
Let's go straight to.
So where the thickness of it is 20. But you're saying from the y-axis now, you know, where is the center of it drop? That's the question I'm asking. Where is the center? Where is the center? Where is y? Where is x2? X2 must be from down here to the center of it. Is that 50?
Yes, sir.
Still 50. Good. And to this one down here is 50. It's going to be 2000 times 50. All right. And then so x bar is equals to, how much is that now? That is 2000 times 50. How much you get? 100,000? 100,000. So for one of them is 100,000. So 3 times 100,000 divided by 6,000 is 50. So it's the same thing. Same principle, depends on whether or not you take it from the x-axis or the y-axis. Is the same principle, and this is known as the first moment of era. Right, so central is really the first moment of era. When you find the inertia now, the inertia is the second moment of era, and what it helps you to do is essentially this topic is going to help you to combine first moment of era and second moment of era, which is the inertia part. Some people call it a total moment of era, right? So that is simple. Let us go back to our slide, please. I trust that you understand that, so we can move on. All right. All right, so let us skip on. All right, so as the slide will just say, using the method of moment, you'll find the first moment of era. Central of an era may or may not lie on the era in question. It is a unique line for a given era, regardless of the choice of the origin and the orientation of the axis about which we take the moment. So, you know, you have to be careful. Yeah, what we call axis of symmetry, right? And we already tell you what is axis of symmetry, but let's run through it quickly. It is an axis with respect to which an element of an era on one side of an axis, there is a corresponding elementary era on the other side of the axis. The first moment of these elementary era about the axis balance each other. And if an era has an axis of symmetry, then the centroid must lie on the axis. If an era has two axes of symmetry, then the centroid must lie on the point of intersection of these axes. So for example, in our case there, it will be where X and Y intersect, and you'd have one being 50 and the other one being 70. So this now shows you a typical one for a rectangle section, a rectangle which is a regular era, and you have the axis of symmetry XX and YY, you cut it to X plane, Y plane. So right here, so is the axis of symmetry. Intersection of the two axes give the centroid of the rectangle, right? And if you go now in terms of calculus, it's the area of each section. So it's dA times X is equal to A. Moment of area of dA about the y-axis cancel each other, right? So it's dA times X plus dA. Automatically, they're saying that it cancel each other, right? So it's a second moment of era in respect to the distance from, it's really supposed to be from the center. These are not looking too much like center, but it's, whoops, but it's really from the center, right? Now, what is the area of one little segment here? So it's this, if the total, if it's, the breadth is across here, so this is breadth over 2. If the depth is D, then this is D upon 2. So the area of this is equal to the area of that. And if you take a moment, there's certainly cancel out each other, right? No, so that's for a rectangle. So for a rectangle, we also know that the area of the rectangle, we say, is breadth times depth, eh? So that is the simplest one that we have, term of system. Now, some of you may have seen a figure like this, and you may be asked to locate the centroid in a figure like this. All right. Now, if you're asked to locate the centroid in a figure like this, you can, as you may have been taught before, this can be done in several ways. You can do it by introducing other sections to it, but you would have to consider those as minus, or you just do it as it is. Some of the things you have to know, of course, is how to find the center of a triangle. You already know to find the center of a square and a rectangle, because those are easy. But what about a triangle? There's a rule that says that it must be 1/3 the X and Y component for a triangle. After you know that, you can do this. So we can actually look at this now and do it. This is what we call a composite figure. And we should be able to locate it. So on my slide, I do it several ways. I'm not gonna do it like how. So I'm gonna copy it, and we're gonna go around and we're gonna see how is it that it's done. This is what we call a irregular one, right? So I have it in the slide, and I do it one way, and I want to, I'm not gonna do it that way now. We're gonna do it, so I'm gonna ask you to participate, and I'm gonna put this here, and we're gonna discuss it. All right. So I want we to find our centroid of this figure in respect to the x-axis. So we're gonna work for the x-axis. So we must tell you in respect to which axis. If I ask you to do it and I don't tell you in respect to which axis, then it's erroneous. you may make the assumption and say it's the x-axis if I not give it to you. But I could ask you to find for the y-axis too, but it will mean that you'll find what? X prime. And if I ask you to find the x-axis is the y bar I want, right? Or so I could ask you to find either the x bar or the y bar from the center. I have a coordinate. All right, so this is respect to the x-axis. So I'm clarifying myself. So you're gonna find the centroid in respect to the x.
Sorry, did we share your screen?
Oh, you're not seeing it? Oh, I'm sorry. Oh Lord, I'm here writing to myself. Sorry about that. So in respect to the x-axis, all right? All right. Now we can use a table form with this. So I could introduce you to the remind you of the table format. Want us to do it? Table format. Let me just see if I can draw the table format here. So I'm gonna use the table format to just reintroduce you to its format. So all right. All right, come behave yourself now. Don't mess up. Listen. All right. No, so we're gonna start with the areas. We got in terms of how they look. So we're gonna decide on the areas that we're using. So on the section. So I'm gonna separate these into areas. All right. And so I'm gonna separate into 3 areas. We're gonna call this one A, this one B, and this one C. Now, area A is a what? A triangle. Everybody agree that is a triangle? All right. Uh-oh. Shortcut. I could put the shape too. And then this one is a rectangle. A rectangle here. We can separate them. And then the last one is a square. All right. All right. So the actual area, I'm gonna put it here. I need more space, you know. Hold on. All right, I'm gonna just drop this here. So I'm gonna call this X and Y, and then I'm gonna call this AX and call it AY. See if I can save some space. See how that works out. All right. And this is the total line. All right. So the area A, area of triangle, is equals to half base times height. So the height is 3, and the height is 3, and the base is 3. So that gives me 4.5, right? Correct? That's positive 4.5 for the area. And all right. What about B? The area of B is going to be 2 times 3. So that's what? 6. Agree? And the area of C is 1 by 1, is a square, so it's 1. All right. So right there, so we have the total area. The total area is gonna be equals to what? 11.5. Am I correct here? All right. Now, we are saying 0 is right here. So for the first one, in terms of X and Y, we want to find where the X lies. Now, I told you already that for a triangle, you have to multiply its width, its base, and its height by 1/3 to find your X and Y to see where the center of it is. Because essentially, that's what we're doing. So you get it at, it says at 1, 1. So the center is lying somewhere here. So it's going to be 1, 1/3 of 3 is 1. And this 1/3 of the height, which is 3, is 1 also. All right. So your X and Y would have been 4.5 here still. Because you're multiplying the area times X, which is 4.5. The area times Y is still 4.5. So you have that. Now for your rectangle now is, we already know what is half the base. Is going to be what now? This is going to be what? -1. Everybody agree that it is -1? Is a coordinate for X? Anybody disagree there? And for the height, it is 1.5. Any disagree out there? Positive 1.5?
Sir, I can see the X1 again.
The X1, you're going from 0 down this side, so the -1.5.
Oh, yes, yes.
What?
yes.
So -1 and -1, pardon me. So it's -1 from here is -1. But this and the center, so its center is going to be 1 wherever 1 goes, and half of this is 1.5. So it's somewhere up in here side. That's its center. All right. The next part is, so we multiply them now, and you'll get what now? This will give you what? -6, and the other one will give you what now? -6 times 1.5. How much is that? Anybody following me? That's what, 9? The square, how about the square now? The square, what is value of X or the square? Right down to half of the square is what? Says half. So down to its center, there is going to be what? -2.5. Do you agree with that?
Yes, sir.
And for the Y is what? Half? Call it 0.5 positive. So this one is gonna give you what now? 1 time this gives me what? -2.5. And 1 times this is gonna give me what? 0.5. All right. All right. If you were to add these, what would you get here somehow? And I using the minus. I probably shouldn't use these minus, you know. But all right, I'll work it with the minus. Let me see. So that, how much is this? Should be 8.5. All right, so I'm getting what here? 4. I don't know why I'm putting the minus in it. You know? I probably shouldn't put those minus there. Those are 4.5 plus 6, 2.5. All right, so let's go. All right, so where we reach now? So this is giving us what? Minus, what is that supposed to be giving us? Minus something. So it would have been 8.5. So it's 4. All right, so that gives us -4. What this one gives us now? The next one would give me what that now? All of that add together. So that's what's that? 14? Yeah, so your next one is 14. All right, so that's good. So therefore, from that now, I can find the sum of x bar is the sum of the sum of the area area x upon the sum of total area. And y bar is what now? Is the sum of y area y times sum of a. So this one now is going to be, you look into this column and it's what? -4 up on total area is 11.5. Right? Somebody can work that out, and this y bar is equals to 14 upon 11.5. Right? All right, so what that equals to now, please, is 4 divided by 11.5. Such a small figure. So it's minus 0.35. Right? Or if you want to put it to 4 significant figure, you can call it 3.48. Right? And this one now is going to be what now? 14 divided by 11.5. So that is going to be what now? Come on, where is my pointer? 1.217. And these are, the measurement was in what again? Meters. So, right, so we're saying that, and this is one approach, and this is our composite figures. So actually, where's the center now? The center is going to be at 1.2, which is probably somewhere up here. And it gone over the negative, which is about somewhere over here. So this is the center of the figure. Center of the figure lie right there. Where is the centroid? Right there. All right, so it actually gone over in the negative. If we had used these as positive, then it wouldn't tell us exactly where it is. So we had to be exact using those negative points. Because you would have got positive 4, it would have been over here, and you think it's somewhere over here. But it's actually over here. The fact that we need to use a negative, actual negative points to read it. All right? And this is a table. Anybody remember doing anything like this? Hello?
Hello, sir.
Pardon me? Hello? Anybody remember doing this simple central thing? You were saying what? No?
No, sir. I remember doing this method.
That is not for everybody though. I know some person said I did it before. Scott, you did it before?
I never do the table. Never do the table.
You never what?
Do the table.
Oh, you never use the table? Only
No.
the formula that I used before. First moment formula. Right, so this is a table one, and this is what we call composite figures. All right. So all right, so the rule says for a triangle to find the center of a triangle, it's not just like a length that you can say is half, like a rectangle and a square. You have to take 1/3 of the component of the x and y. So in order to get the center of the triangle, I had to take 1/3 times 3. So that is gonna give me what? 1. Right? And that is for the x, and I do the same thing for the y in this case, because from here to here is 3. From here to here is 3. So it's 1/3 this, which is 1. So wherever 1 is, drop in there, I get the center. So I know, so that is what I'm supposed to be using. So that is how I use 1 1 there. For all of those persons. Half of 2 is 1. So but I know this is -1. So I put -1 here. Half of 3 is 1.5. So see there. So that says half for the rectangle, and the square is half. But for the triangle is 1/3 the length, the base, and 1/3 the height to get where the center is. Because remember, we have to read it from wherever the center is to get the moment, you know. So that is what we're doing essentially. It's from the center to the axis. Vice versa. Whether the X or Y is the center down to them, center of the figure. So you have to find the center, wherever the center is down to here to read them off. So I did both for the X and the Y. So for the Y is 1 and for the X is 1. And the fact that using the table, it tends to allow you to do both the X bar and the Y bar same time, right? And that is the essence of it. Now, what about the square? The square went down here, so half of this, half of 1, half of 1 is half. So therefore, I had to read it down to 2.5, -2.5 actually, because this is 0. And for the Y was easy because it's just half of 1, which is positive half. So I put it over there, and then you just multiply across the area time each one of the components them. So you get AX and you get A1, a column. And you just take them off separately. So for the X bar, it's the sum of the area of X divided by the total area, which is this guy here, right? So this is total area, right? So it's AT. And the similar for Y bar is the sum of AY divided by the total area. And so it's 14 upon what? 11.5, because that is 14. This is 11.5. So that is the actual symmetry for the figure. All right. Now we don't tend to give inertia for irregular figures. So you wouldn't see one of these that are asking for the inertia, because it's a little bit more complex than a regular. So most time we ask about inertia is some regular figure, right? I was planning to give one with a circle this time around, but that has changed. So we won't get a circle one. But what I want you to understand is also for circles. You need to understand some concept for the circles, the square, and so forth, to be able to do these questions in a competent manner. All right, so let us go on. Let us go back to our slide. We pick up from where let's get back to our main core. All right, so we see it. The example that I have on it, do it. What they did is to actually fill in this area. If you put in that area, you'll have to consider it a negative area though. So that's how some people tend to do it. So you see what they have done? They say it's composite plate divided into 3 parts. So they fill it in. And then take that part out there separately, that, and these are called these 2 separate parts. So they fill it in. Right? Unlike what I have done, them fill in that area. Right? So them fill it in, them call this area 1, area 2, and them call that a separate area. Of course, this area is going to be a negative area. Let's look and see how they done. So you see the similar approach. So I show you 2 approach. So what they have done, so the area of this would have been the area of the first figure, the triangle. So you have area 1 is a triangle, right? Yeah. So area 1, the triangle says half base time height, so it's 4.5. That's what I got to have. The other one was a rectangle, right? That one was a rectangle. So it's 3 times 3, 9. And then the last one was a rectangle again, but it's a negative area. So it's -2. So it's a minus area you have for and this is for the piece that they had it. See it over here? So the area from this that they had it. How did they get that from here? So this is 1 times 2. But they put it in as minus. So you have a minus area there, right? So the total area is still 11.5. And then know what they did with the triangle. They said they take 1/3 of the length of it. Okay, it was 3, so they get 1, 1, same thing. And they multiply it across, it's the same. And what they did for their rectangle now, they found the center of it. So they said the center of their thing was minus 115. Right, so the center of it was minus 115. And the height is 115, but this is negative 115. Right? So x is negative 115, that is positive 115, 1.5. And they multiply those, they get 13.5. Then they multiply these by area here, so you get 5 and minus 4. And they add them again, so you get minus 4, 14, and they work it out. So those are the values, just like what I got. Right? So we need to move on. All right. Now this is another one which has area in it. It's on the slide. I don't remember if it was worked out. I think it was worked out to some extent. No, let me just check. No, it wasn't done. You know, it's on the slide, but it's not worked out. That's something that you probably can do as an exercise for practice. All right. This one though is another one, and this one is pretty much worked out. You separate it into figures, shapes just the same. So you'd have had a half circle here, right? So then now you'd have to know how is it that you find not just the area, because the area is easy, but whatever the area is, it's going to be minus area, right? So they call this part is, so they fill it up and they call it as a minus area. So that's half of a area of a circle, but that's a half of the area of a circle. All right, so whatever is radius, you know, say, and you find the area, but you half it, right? So you have had it there. So that is minus, where is it? Not minus, minus 1414. That is its value. Pi r square divided by 2 would have given you that value. So they divide it up into different figures here. They also have this. So it says another rectangle, but they have that as one area, and they have this as another. Right? Right. And they have that. Right. So what they did, coming up to here, more likely they would have had that as 120. So right. This negative here, they have it by itself. So this is a negative here, this is a negative here, because those are empty. These are positive here, positive here. So they have them. So 1 and 2 is positive here, so you know the values are positive. The other 2 are negative, so they are negative ears, and it will reflect into the calculation down there. All right, so you can look it over in your time. This area would have been 120 times what? 60, right? So you multiply to get the 1200. You do area 2. Area 2 would be the triangle, and that would be what now? That looks like, I'm not seeing it perfectly. It looks to me like, what's that? 60 times the height. Looks like 60 is the height, and hold on. Why will we have 100 there? Just double checking the measurement that they have. 120. This down here may be a little bit redundant, right? See why they're having 100 here. I cropped it out, never even pay attention that they had the values here. But this is all right. This is 120, which is coming right here. And this is pretty much dropping down right here. I'm sorry, this is 100, yeah. Yeah, so that's 100, yeah, that's correct, and that's 120. I don't know why I was seeing something different here. I'm sorry. Just look like a different. So probably I'm tired. So this is 120, 100 here. All right, as I said, this is a negative here. So you know what this height is already. It should have been 20 times 40. So you have it down here. Where is it? Sit here. Minus 800. And this would be pi r squared divided by 2. So you all of those, you multiply them across, right? Right. Area 2. What are they doing in area 2? What was the distance here? Just checking what is happening here. Area 2 is a triangle. Okay. Okay. So that is. All right. Now, two things you need to remember here. When you are relating to the center of them, you'll have to come back to right here, to the 0 point. That's very, 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 very. So when you're finding, let's say for the first one is a what now? The first one is the rectangle. Let's look at it. So half of it would be what? 60. Half of 120 is 60. So it's 60. What about the height? Half of 100 is 50. So see there. So x is 60 and y bar is 50. So for this one. And then for 2, let me see, they would have done, so they're trying to find, for this one, they would have worked out. What would be the dimension here? This looks like, so they're trying to make it out. This looks like 60 here. All right, it looks like 60 coming down from here. 60 times, and this, the height is 100. All right. So they do 130 of that. All right. Right. 130. So this is 100, right? So it's 130 of the height. Now 130 of this is supposed to be 20. 130 of 60. It looks like 60 to me. You drop down here. I'm thinking that this looks like it's pretty much halfway. Am I assuming, or the measurement is actually there? Let me just double check it. So this is 20, but it looked to me that this is halfway here. All right. Let's double check that. All right. So that automatically means that would be about how much is that now? 180. Is that looking like 180 to me? But then now you'd have to take 1/3 of this. So 1/3 of 60 is 20. So it's 20 plus 122. So that gives you 140. And you take 1/3 of the height, which is 100. So you get 100 divided by it's actually 33.3. Right? So right, so you use the 1/3 rule just the same. For this one, it's going to be, what's the measurement you have up here now? So this is half. So this is the center. So you have you know the center of it already. This is 30 and that is 30. So that is 60. What about up here? Up here is going to be not half. I think the rule would have there's a rule for circles. You can just go into the tables and look what is the rule for the circles. So I can tell you the rule for the circles. Right, so all of them have a rule, but the most important one that you need to remember is a triangle, but all of them have a rule. Right? And you have to look for the rule that applies to each one of them. Right? I'll remind you about the circle one. I'll do a little rain check on the circle just to update my memory as to the circle. Right, so I'll update you as to the circle. Why is it that it is here, that this is 12.75? It's not 15, so it's not that we use half. There is a little ratio that they use. In fact, that is a circle. But I'll update you as to what we use there, right? To get that value. I'm trying to, I think I do have some of the content in the notes. What we do with the circle. But I can't remember right now what for the circle itself. But as I said, all of them are specific, right? I'll check on that and tell you how you get the 12.75. So you use the same table using the principle across here, right? And it's pretty much you just use the table method as I had shown you just now, and you get them. All right, so that is for that one, all right? Oh, this is actually around here. So this one is actually worked out, yeah. So I did find it's fully worked out. So you can have a look at it. And this is this one here. So it's actually at the wrong place. It's there. I know that I normally wouldn't put it there without having the full workout. Right. So it's there. And it's fully explained. So those are all right. Classwork. I want you guys, what time do we have now?
None.
Oh, last time finished and I haven't even get to look on the lab. All right, I'm gonna pause here. Let me just sail into the lab and just show you something. I tried to open the lab and just check to see if, I hope I didn't close it. Wow, I wonder if I did accidentally close it. Can I take a little time to boot up it? Hold on. Take a little time to boot up. But I know I had opened the, oh, here it is. It's there still. Let me see if I can share it. All right. The lab that I'm considered doing, it has, I don't know if this one is the correct one. I'm looking. Yeah, it's probably gonna be something like this one. Can you all see it now? So,
Yes, sir.
right. So you have bricks here, and you can actually load it. And I think I send it to you. So you can actually load it. Right. All right. So we can use it. It's almost like doing a shear force lab. But I have not fully come up with all of the concept of it. That's why, but I'm just showing you. All right, so you could load it. So you can have different levels here. You can have mass of label force from object, the levels, position, the ruler. So you can show a ruler too. All right, and you can mark it underneath where you put each load. All right, and of course you can take out. When you do that, you're actually moving the support from underneath it. So, and then now the challenge is when you do that, you could now start to put some load and see where you would balance it from. Would you put more? Wow. Where else could you put? I'd say it doesn't go on down totally. Let me see. We'll put another one here. It says no, it reject that. Because look on the mass that you have across here. Says what? 20, 20, 15. So that's what? 55. And you add up these, how much you have over here now? So you have 50. Am I having 50 here? And this is, so it's 5 over. So it means if I put another, so you know, if you put another one somewhere over here, hold on, no, hold on, hold on. Hold on. No, how much I have there, so that's 20, 50. Oh, so why is it unbalanced? All right, let's see. All right, it depends on the distance. What is also showing you is the distance you put the load. All right, so let me put another 5 over here, see if it will take it. All right. So the question is, what the lab is setting up to do is for you to actually calculate the distance using in terms of how you balance it. This is one of them. I don't necessarily know if I'm going to use this as a lab, right? But there's also another one. This one is, there's also another one. So you can actually put force to it. So I'm still experimenting with it to see how it would work, if it would work fine for us. Right? Oh, you have to take off some of them lower off of it. You can actually remove one. Right, you can remove it. No. Right, so we can play around with this, but I will I'm gonna tell you more about this one next week because this is definitely gonna have to do another lab. There's another one where I have I think I sent it to you where you actually put the load on it and the beam bends. That's probably going to be the one that I'm going to use. All right. So I will I'll tell you some more about it next week. All right. The one where you put there is, I think it's the third lab that I put there. It has something about it's a mechanical lab, which I think is more appropriate for you. It's just that they take a long, when you click on it, it takes a little while for them to load. And I was hoping that this was the correct one, but this is not the one. The one that I have, when you put load onto the beam bends. So we could actually do a shear force bending moment lab by the amount of, so you could actually say based on the load that you put on it, you draw a shear force and bending moment. That will give you more practical application to me than this one. This one is when is more a high school kind of lab. It just doesn't, you're just gonna use a moment equation, right? This one is loading, but it's loading slow. It's just reached what, 15%. But they take a little time to load. If you want to give me another minute, it should load in another minute and a minute and a half. I could see if this one is the right one. But there are two. So that one is one that, to me, that is a little that's not at your level, right? It doesn't really test anything significant, right? Just remind you of your O-level labs. Because I have, normally with the class, I can do a friction lab. We have friction board and we have a friction lab. All right, it's reached about 50%. Let me see if this is the correct one. Give me another few minutes to see if it's board. %. So you may have seen the lab and you don't know, but I'm considering the one to do is the shear force and bending moment. No, this is not it. All right, tell you what. Look for the shear force and bending moment lab that I sent to you. If you don't have it, I'll double check to see if the one that I sent to you is a shear force bending moment. See that everything is together. One that actually loaded a while ago is the paragram of forces lab, the same force table lab, right? So, and by the way, anybody want to report on the lab you're having difficulty with that lab, the lab should be easy. So you're gonna use a parallelogram of force. When you finish, you draw your either you draw a triangle or you use a parallelogram of forces to do that same lab there with the force table. In fact,
So
mhm.
about the bridge project thing, the documents that you have on Moodle, they're not correct. I want them correct and I want the Rubik.
You want to do what?
The Rubik. You did go through one document in a class where they tell you what type of module you can use and all that stuff. That one is not on Moodle.
Which one is that, Moodle?
The one that we were going through, the one that got in a class.
You mean I show you a Rubik, so I'm going to mark it, right?
Yes, that one is on Moodle, but the one with the info, with the information, I think with the different type of bridge and all that something.
But you can do research, you know, because in your notes, you know, it's in your stress notes. Some of it is in your stress notes. You don't see it in the stress analysis notes. You're not seeing it there? I know it's in the stress analysis notes. It should be there. From what I recall.
But two documents so we have a bridge report. What you open it, I beam notes of come.
Hold on. I'm right there now. I'm looking. Hold on. What you say now? What is coming up? Let me just clarify what you.
When I click on project report, I beam notes of come.
Oh, when you click on bridge report, let me see what's coming up there. Hold on. I don't know. Why is it that I can't see what is in there? Hold on. It's not giving me access to see what's inside there, though. It shouldn't be. Hold on. All right, I'm gonna review it because I need to see what's turning on editing. Let me see what is in it. You're saying the bridge report, nothing is in that, whatever is in it is incorrect?
Yeah.
All right, you see on the classwork in stress analysis, in that note you should have, let me look in it. The stress analysis, you should have some of it start to tell you some stuff about bridges and so forth. Let me just double check. See if this one has it. Yeah, man. So it says common type of stresses. So it give you some name of them. Let me see how much it give you. So it give you some common type of stresses. So you have the Pratt, the Owie, the Warren, Baltimore, Parker, subdivided Warren, K-stress. Yeah, man. You have some there. So you use those as where you would start and look. Those are the types. All right, so you have the Warren and the Pratt and all of those. Those are what you should use. The bridge, let me see what is going on down there in bridge report. See if there's anything. So you're saying nothing is in this bridge report here. You're saying there's not much. It's empty. It should be empty.
So when you click project bridge report, you have some beam, something come up there like notes.
Oh, yeah. Oh, hold on. There's two of them I have bridge report. Oh, but you're saying some stuff come up. All right, let me just go in and say editing. So that we can see what is there. But I want to see what is it that I have placed there. But it look empty to me. I'm not seeing anything there. I just put update assign. Oh well, hold on. Is it the correct thing I always went into? Let me see. I have bridge report here. You say when you're going there, you're seeing stuff inside there?
Sir, you have bridge report. I have another one when in project bridge report.
Oh, you mean static bridge report? It means
no, sir, the one above that, sir.
Oh,
there when you
Oh,
click
that's what
that,
you're saying. Let me
beans
look and
come
see
up.
what is there. Let me see what is there in this one. Oh, pardon. Guys, those are not the assignment. There's one for submission, and there's one that I. Oh, okay. Oh, so you're seeing these are different files, isn't it? The file is incorrect. Hold on. The ShareForce notes is there. That's what I'm seeing. That's what
Right,
you're saying,
right, sir.
teacher?
Yes, sir. Yes, sir.
Uh-oh. I realize that. So hold on, but the ShareForce notes, that's the only place where the ShareForce notes is? Or is it stress analysis, ShareForce? Hold on. Oh, what are you supposed to name ShareForce notes? I'm sorry. It doesn't need to know. Oh, so the names here are wrong. All right, thank you. So I have to fix that. You have project report and static bridge report. Those are incorrect. So one of them is which one is the correct one now? The labeling, okay. Okay, I see what is happening. So, all right, I need to change the label for one of them. I'm gonna edit it right now. So the label one is supposed to be ShareForce notes. That is what it's supposed to read. ShareForce, I'm not gonna delete it. ShareForce and bending moment. All right, but you're saying
But sir,
I
yeah,
can
share one
short your
document.
information.
You did a share one?
I was sharing some other stuff to you and you didn't
Yes.
get it. That's what you're saying. Okay.
Yes, sir.
Right. Okay. All right. I also some of the details that. All right. That means you lock some detail. All right. You have to tell me, you know. Tell me if you say that I didn't give you bending moment, ShareForce and bending moment. All right. So this is bending moment notes. So it's not supposed to name any report. Yeah, that part is wrong. Bending moment. And I put notes so that it's clearly, you know that that is notes. All right, so I turn it to notes now. The bridge report wants some more information there. So it's only rubrics you have here, so. Oh, you will mark the bridge report, so you don't get anything more than that. All right. I need to load some more stuff for you on the bridge report. All right, so I need to put a file up with bridge report. All right, let me do it immediately now. Everybody register. Let me take down the names first so I don't lose that. And then I am going to edit that. All right, so everybody look out. Remember, you're getting a little quiz. Speaking again, frameworks, and so please practice and possible some equivalent forces. All right. All right, so that's it. I will update. I'll send you some more info. You didn't get it. I probably think I put it up, and for whatever reason it was deleted. So I will do it again. All right, thanks for letting me know. What's that? Come again? What was that, Roden?
I say like information you have to extend it.
God, man, Roden. Come on. I am going to give you some more information, but that doesn't need any extension. You already have enough time. We give you enough time. If you're having difficulty, all you do is contact me. All right? Simple. All right? Simple. You can't wait till last minute to contact me and say that, oh, you never understand everything, whatever. I tell you already, is pharmacy and supermarket. And listen to me, I've had other class and nobody never give me a problem for do them little thing. Even I've had 2 other classes, a day group and an even group, and everybody never bother me if I want to tell them what to do with their project. So you guys don't let me down now. All right. You can do it. You make up your little fudge stick thing and load test it. You want to do something. It's just for persons who want to make it difficult just sound lazy. You just want to do something and say you get a paper and run off. You don't really want to understand what it is that you do. That is what it is saying. It's a very bad reflection. All right. So I must cheat you and let you not do anything. Come on. Every group has to do their project. So as a team, we find a way. Here you do the project. All right? Simple. If there's an issue. But you must do your project. All right? If you're having difficulty, we discuss it and we work through it. But don't wait till last minute and tell me, oh, you know, boy, I just never get to do it, you know. Because you're going to lose 15%. Can you imagine?
Excuse me, sir. You take the register?
That's what I'm doing now. And that's exactly what I'm doing. Crawford. Crawford, are you still here? You weren't here yesterday, you know. And the principal is Shah and Hayan. Want to know if people attending classes. And knowing I checking. So all right. So the last person registered was at 8:45. Mine you just coming now. Davis, mine you just come pushing your name.
No, sir.
I weren't here.
No, man, they a long time, man.
You'll be cheating yourself. Yo. All right.
No, man, they a long time.
All right, man. Good. All right.
Yeah,
So
but
hear me
just
now.
go and come sometime.
All right. Guess what?
Sir, I need you to check your email to you, sir.
All right. Which one of the emails I must check? I have so many of them. The PCC one, because that one give me a little problem now. I need to check. Send it to either the Rev or the Gmail if you don't get a response. Because sometimes the PCC one tend to give me a problem every minute it want password I don't understand what's going on with it. I synchronize it between my Gmail and it's still giving problem. The Gmail don't give me a problem, the other mails don't give me any problem. Every minute it want to see if it's me. I don't know what is going on. So,
sir,
yeah. So that's sometimes I haven't
PC.
been it the last 2 weeks or 3 weeks. Yeah. Every minute I have to go look for password and go in again. I can't go every minute.
Sir, you can tell me the other one.
Which other one?
Tell me the other one, sir.
Other one. Oh,
I only know the PCC one. I don't know the other email.
You have a Gmail, man. It is the same one that I would have share your videos on. The OneDrive. Well, I don't know if the OneDrive probably wouldn't give you an email, eh? So there's revvb@yahoo.com. That's my most personal mail. I don't necessarily like you guys sending me in that one, but I mean I can't kill you if you're the emergency you have to send me. That is one. And you have the other one, the Gmail. Let me tell you the Gmail. The Gmail right now is working better because it's synchronized between the PCC mail and this one, but the PCC is giving so much problem. All right, let me tell you what is a Gmail. I just want to make sure that I'm spot on and giving the right.
You need to verify yourself, sir.
What?
You need to verify yourself so you will know it says you.
I don't know. Yeah, I suppose I need to do something like that. So this one is revvb@yahoo.com. Let me just see. So it's revvhb@gmail.com. So that's a Gmail one.
All right, sir.
Yeah, so it is revvhb@gmail.com. That is that one. All right. Yeah, so I'll try and put up some more stuff for the bridge report, since that you said that there is lacking information. Yeah, everybody should buy up your fudge stick long time and start their thing. Do a little research, and get going. All right, but anyway, before the night out, I'll load up the rest. So I'll have the page open and I'll load up the rest before the night is out. All right. So just prepare yourself for your little quiz this weekend. I don't call them tests. What I'm going to do with the quiz, I'm going to average them out for your final test grade. That's what I'm going to do. So it's every unit I'm going to give you a little quiz. So you won't bother getting a one test. You get a chance to so all of those persons who just try and maximize on them. And I'll give you enough so that you can get a good grade. If at the end I see people being weak, then I'll try and give you a one test. So I do something like that. Combine it, probably just combine the questions them again and give them a one test. Just if I see the persons are not making it through with good grades. All right?
Sir.
Fair enough?
Yeah, Mr. Brown.
Yes, man. Mm-hmm.
Yeah, man. I'm about to review the 2 questions.
No, I don't review them yet. I'm going to look through it though. I remember the question that Brandon said, and there's one that you said that there's no information there. I'll check it so that you're not penalized for something for my mistake. So I'm going to check on that question. I think I know the question. That I saw it and I was wondering if there's more information there, but I'll check on it. All right? I remember it. It looked like a 3D problem. I remember it. All right. My first time setting up material on the Moodle in terms of the quiz. So bear with me, and I will I'll make sure that I don't penalize you for my efficiency. All right. Fair enough.
All right, sir. All right.
Come on. All right. Okay. All right. So I'm not even gonna shut down. All right. I'm gonna end the meeting now.